I think we're still pulling up the charts. Let me ask you a question. How many here have been on a cruise? How many here have been on a cruise with Royal Caribbean Group? Now, before you answer, Royal Caribbean Group includes Royal Caribbean International, Celebrity, and Silver Sea. So one of those three. How many have been on some other cruise line? What's that? Sorry, say that again, please. No, but you can, if you go to our website, you can get some really good deals. So how many people here went on a cruise more than 5 years ago? How many have been on a cruise since the pandemic ended? Okay, good. Well, I'm going to talk a bit about that today when we get the charts up. But you know, in fact, I may as well talk to them when they come. You know, the cruise industry was hit really hard by the pandemic. Now, the whole travel and hospitality area was hit really hard, but I think it's safe to say that cruise was probably the hardest hit. You know, our revenue went down to zero starting in early 2020. But the good news is that we're totally back now. We're actually performing better than we were before the pandemic in terms of average pricing and you know sales on board and so forth. And that seems to be due to a shift in people valuing experiences over things. And maybe that came from the pandemic when all we had was things in our home, right? And the experiences. And then there's another factor people call revenge travel. And so those two things, you know, I think revenge travel, some people say may be transient, but there does seem to be a secular shift. At least we hope there's a secular shift in that valuing of experiences over things, and something we call the value gap, which is the fact that if you look at cruise-based vacations compared to land-based vacations, we've done some kind of rigorous things to try to make them comparable. The cruise-based vacation is way cheaper than the land-based vacation, so we call it the value gap. Naturally, we'd like to shrink that gap a bit, because, and that's really the way we look at our business. We're not just competing against other cruise lines. It's really competing against other vacation options that people have. Well, what I'll do too, if I can give a bit of my background. I have a chart on that, so we can skip that chart when we get to it. So my journey, I actually started as an academic. I was a professor in the 1990s at a university, and I left that to start a company. So I became an entrepreneur later in the 90s. Then after that, I joined IBM Research and spent about 14 years kind of plumbing the depths of research. And that's where I first started learning a lot about the new machine learning techniques and trying to apply them to business problems and such. And spent time at IBM Research, going through all kinds of applications of machine learning to different kinds of business problems. Then I became the Chief Data Science Officer at GE, covering all their different business units. And then I founded a AI as a service startup, Noodle.ai, and was the chief data science officer there. And then about 4.5 years ago, I left that to move to Miami. I'd never been to Miami before. Moved to Miami to lead the data analytics and AI area at Royal Caribbean Group. All right, 3 topics. We're going to talk a little bit about cruising. I think we started that already. Then just AI, GenAI, digital transformation, and things like that. And then some examples that we'll give that we're doing particularly in the cruise industry. So first, a bit more about our company, if you're not familiar with it. As I mentioned the different brands that we have. We have about 100,000 employees, and like a hotel or an airline, the vast majority of those employees are crew on the ships. Our sort of corporate core is more around 7,000 or so, I think. We did approximately 6 million guests in 2022, and we're always adding new ships, and so these numbers keep increasing. We have 2 private destinations currently, and we're building more. These are private islands that we basically own and can kind of manage and facilitate the experience that people have on there in a much richer way than is possible when we just take you to some other port. And we go currently to over 1,000 destinations on all continents, but we do an especially lot around the Miami area. Our ships vary from our smallest ship, the Celebrity Exploration, which, for example, goes to the Galapagos Islands and does things where you can really only have a small ship, to the world's largest cruise ship, which is Wonder of the Seas. That's in our Royal Caribbean International brand, and that'll soon be supplanted with that title probably in early next year, probably January, where we're launching Icon of the Seas, which is a whole new class of ship, and it's bigger than this, and it's really amazing. If you haven't heard about it, I would suggest Googling it and learning. It's an amazing ship, the first of the new Icon class. And overall, we have 64 ships in total, with 10 new ships on order. And we would get more ships if we could, but there's only a few shipyards in the world that can actually build ships at this scale. Okay, next chart. So I've already talked a little bit about cruising, but just get value, as I mentioned before, about that value gap with land-based vacations, and just the rich things you can do. A cruise ship, again, for those that haven't been on it, especially if you're going to one of the larger ships, it's basically a theme park on the water, you know, with fine dining, with all kinds of recreation and so forth, stopping at all these different ports. You keep your same room over all those stoppages, and you get to do all kind of things, and there's a lot of options. You can curate exactly the kind of thing you want to do. So I think, and again, I'm new to cruise. I never cruised before joining the company, and I've, you know, the scales fell from my eyes when I started seeing what the value proposition was. So, getting down to the substance of the talk here, I'm going to talk at a bit of a higher level of abstraction than our previous speakers did, and just talk a bit about how there's opportunities for self-reinforcing activities you can do to make the customer have a better experience and become a more loyal customer over time. And this ranges from the first process step, where you're planning what cruise you want to take, what your itinerary will be, what you're going to want to do on shore and so forth. Getting to the port, you know, they may live far from the port, they'll need assistance getting there. The whole boarding process, the cruise itself, that should be a bigger box, obviously, because that's the core of the experience that people come for. Then getting off the ship, getting back into the country where you're going to, getting home. And then really important is that ongoing relationship. It's especially important in cruise because even a frequent cruiser cruises maybe once every 18 months or so, right? So we're not going to be doing business with them directly again. So we look for ways to keep that ongoing relationship with other kind of offerings and just you know, keeping them aware of what's going on. So I'm going to show a few charts here, which some of you may have seen before because I've presented before, but I've been told it's helpful just to give people a view of the numbers involved in the cruise business. So when I first joined, you go to like a revenue management meeting, you see things like 60,000 system calls per day. Now, system call is basically a indication that someone has gotten far enough in the online, in the purchase process, that it queried our reservation system. That's basically interest in reservations. 5 million price points in the market. Cabin inventory on average at a given time is 50,000 or so, 120,000 price changes per week, people coming from 160 different countries, and 6 million guests per year and growing. Now, we have some people from our team working in revenue management here. Some of these numbers we might need to update, right? They've probably gone up. So an AI scientist walks into a marketing meeting. So we have a customer database of about 100 million people. About 1,200 raw dimensions, so raw fields in that. Obviously, when you do feature engineering, that number explodes pretty dramatically. We send out about 3 million emails a day, about 2,500 different promotional variants, and about 2.5 million website interactions per day. And these numbers are going up with some of the activities we've been doing recently. This one's really interesting, supply chain. So for a single 7-night Caribbean cruise, this is the stuff that has to be loaded onto the ship before it takes off. And they only have a small window of time because the ship comes in the morning to finish a cruise. They have to get all the junk off and all the people off. And then they have to reload all the new stuff and get all the new people on. So this happens in a matter of hours. You know, 35,000 pounds of protein, 47,000 eggs, 32,000 bottles of beer, 21,000 ice cream cones, 2,000 pounds of coffee, 11,000 hot dogs, and 10,000 rolls of toilet paper. And you can imagine how that goes on and on for all the different things that are on the cruise. So then the AI scientist reflects on these numbers, because the numbers just, the data and indicative of activity happening. An AI scientist starts asking, well, what can we do with this? So they'll say, how can we best measure customer experience? So not just NPS, right? But how do we best measure the real customer experience? But more importantly, how does it vary with variables we can control? Because you don't just want to know how their experience is, you want to be able to change that. How does food consumption vary with guest demographics? Can we look at who's going to be coming on a particular cruise and decide when to thaw the beef versus the chicken versus the tofu burger? All that kind of stuff is an important thing. Under what conditions can we measure price elasticity? And what covariates are needed. Now, for anyone who's ever tried to measure and in a practical way use price elasticity, you know that if you just look at price booking curves, you won't get anywhere, right? Because there's so many more variables that matter than just the price in terms of predicting the buying behavior. So what other kind of covariates are needed, and what kind of models would you do to make that work? How do we predict guest flow and accumulation rates of people across the ship, so we can make it so queues are shorter and people don't get, different areas don't get crowded, and people don't even know that they're being incentivized to go other places? Can modern consumer choice theory be used to quantitatively determine the optimal promotion parameters across a variety of guest demographics? Why do some HVAC systems behave much more efficiently than others? So these are the kind of questions that you start asking with that kind of data in mind. But let's step back for a second. What we're really trying to do here, right? What it's really about is a digital transformation of a business, right? And why do you want to digitally transform a business or bring AI to a business? We don't have to try to figure it out, because a lot of industries have already become very datafied, have become very much digitally transformed, like financials and banking, telecom, media, the mail order business. And the industries where this has happened, you've seen that there's been massive disruption, massive shifts in who dominates the business, and enormous gains in productivity and performance. And so if we can do this with traditionally less datafied industries, like cruise, like manufacturing, like airlines, like mining, like green energy generation, those industries are going to perform much better. The companies that lead in that are going to outperform their competitors, and the countries that do it better are going to be in a very much advantaged position relative to other countries. So it's a very, very important thing to do. So how do you do it, right? At a high level of abstraction, it's pretty easy, right? You combine data with math, with human domain knowledge, and you basically get models out of that. And then to have it be impactful in the world, you need some ability to deploy that and have it connected to action-oriented systems. And that, of course, means deploying software to do that at scale, right? So that's the action part of it. Now, there's a few other things you need, and we'll get to that in a few minutes. But it's data, math, domain knowledge, and then something gated by software to scale it out and take action. So AI is a huge part of it. Okay, next chart. Okay. It's jumping. Okay. Just in the ending here. There we go. So AI is a huge part of it. But what is AI really, right? Now, this definition you've probably seen. This is a standard definition you use: science and engineering, making intelligent systems that can continually learn and improve over time. But that's not a very helpful definition, right? So more specifically, okay. More specifically, people often talk about three different kinds of AI, right? There's artificial narrow intelligence, artificial general intelligence, and artificial superintelligence. Pretty much everything that we do, and I think most enterprise applications of AI, falls squarely in the artificial narrow intelligence, right? So that's where you focus on a particular business area or a particular business process, pricing, customer targeting, something like that. And you're typically using technologies like machine learning, ways of incorporating human domain knowledge, generating, purpose-generated data, maybe some reinforcement learning, although that's less common. But that's the lion's share of the business impact, at least for machine learning, in most traditional enterprises. Artificial general intelligence, right, is trying to get systems to exhibit behavior that's similar to knowledgeable humans. Something like that could pass a Turing test, for example. And that's been long elusive. People have been thinking it was a few years out for decades. With the recent advances and things we've seen like ChatGPT, people are a little more optimistic that might happen sooner, but I don't think anyone thinks we're close to an actual. It's more and more of the same. And you know, for the AGI, it's similar technologies to the ANI, but you're obviously using much deeper neural nets, much more massively scaled infrastructure, and so forth. And the artificial superintelligence will probably be more and more the same, although we don't know for sure. And as far as the key applications, we don't really know, right? It'll be, if it comes to exist, it's going to be so much smarter than we are. We may not even be able to understand what it's thinking and doing, and so we don't know what it's going to do. And that's what scares some people. So there's a lot of buzz about generative AI, and there's been discussion about it here. Again, I'm going to stay at a higher level of abstraction than some of the other talks. But what's really going on? So one book I would highly recommend, I've read a number of books and articles on it, but this book by Stephen Wolfram. And for those who don't know Stephen Wolfram, he's kind of like the Richard Feynman of mathematical, computational mathematics and so forth. And he writes in a very technically true but simple manner. And so what I think you learn from this book and from other good treatises on it is that it really is surprising that it works so well. It's kind of like what Richard Feynman once said about quantum mechanics. He said, if anyone tells you they understand it, they're lying, because it doesn't make any sense at all. And it's kind of like that with this. The people who made it don't know how it works, right? There's a lot of empirical tricks involved, like you do this here, you do that, and you ask why. Well, it just seemed to work better. And that kind of means it needs to be studied as a natural system in some ways. Like, so for example, if you wanted to figure out, what pressure a coffee cup could take before it breaks, you wouldn't do it from the fundamental quantum mechanics of the atoms interacting with each other, right? You develop laws and rules of structural mechanics and so forth. And likewise, this is something that he talks about in the book. We need to study it as a physical system almost to actually understand how it's going to work, because you can't. It's just too many variables to try to understand it from an atomic level. But we do know, right, that all it really does is given a question, and with some restrictions, like some prompts or things like that, and what it's answered so far, it just predicts the next best word or token, right? That's all it's doing. It just keeps doing that. It's like the autocorrect, it's like the autocomplete on your phone, but like orders of magnitude, deeper and better. Yet, even though it's doing that, it's just word by word, it has an uncanny ability to give reasonable sounding answers to almost any question. And so there's obviously massive opportunity across many areas of a business, really affecting anyone who creates content or answers, including code. And that's what gotten people so excited. And it's going to keep getting better and better. And there's some risks and challenges to using it. Some companies are worried about the risk management and so forth. There is the issue that it has these hallucinations or misunderstandings. For example, it was in the New York Times a few months ago. There was a court case going on, and one of the lawyers used ChatGPT to help write their brief, and it submitted a very compelling brief, and then the other side couldn't find the cases it was citing, and it turns out ChatGPT had made up the cases. It actually mixed and matched from existing judge decisions and made it up. Now, it's pretty bad that the lawyer didn't check his case citations, before submitting it, but it just made up a reasonable judge decision, but it wasn't real. Confusing companies or people because they're generally similar. So I for once asked it, tell me how Royal Caribbean is using face recognition. And it went on to tell me about some of these great face recognition based solutions being done at Royal Caribbean, but it turns out they were actually programs of competitors of ours. But it kind of thought we were the same as that other company. And then there's an absence of actual logic and reasoning. Because of the way we evaluate people, when it does something, we often give it more credit than it's due, but it's not actually doing a logical reasoning, right? It's just basically pattern matching. So for example, one of the examples that's been making the rounds is you ask it a simple question like, Sally, a girl, has 3 brothers. Each brother has 2 sisters. How many sisters does Sally have? Right? It's pretty obvious the answer is 1. But all these chat systems generally say 2. Some even say 6 or 8. But then I just to check it again, I asked ChatGPT last night, and it came back with 2. So it's just pattern matching. Now, the other issues we have, which can be more from a corporate enterprise level, there people worry about data leakage, the fact that your queries might be leaking important company data in a way that can't be protected. Copyright issues is becoming more, especially on the image side, but also on the tech side, that it's the models are being built using some copyrighted material, and you may not have rights to do that. Patentability issues. If you're using some of these technologies to invent things, do you lose some of your ability to get intellectual property protection on those, right? So these are some issues, but there's no question it's a transformative technology. And as technologists, I think most of the people in this room are technologists, we should be super excited about it and be exploring ways to use it. Oh, I just realized I didn't advance that chart. So that's the chart that says everything I just said. Yeah. All right, so I want to step back now and talk about how we put AI-based solutions together, right? So I think it's safe to say there's three major constituents in putting together a solution. There's product vendors, there's consultants, and then there's in-house teams. Now, product vendors tend to be appropriate when the technology is very mature and when you have common requirements across many different companies, right? That's what enables scale. There's a lot of upfront investment to build a product, and so they've got to have common requirements across many customers for them to be able to make that investment. Consultants often work with when the core technologies are mature, because they're not going to invent new technologies, but complicated to integrate together. And for them, they don't need to have common requirements across many companies, but at least many companies have to be working on similar problems. That's how they get their knowledge sharing that reduces their effective cost of service. Now, in-house teams tend to be important when at least a large part of the technology is immature. The core mature technologies that are present may be complicated to integrate. And the intrinsic complexity of the problem or system and or changing requirements across what the system needs to do requires constant adaptation. So if you need to constantly adjust a system, you need to have people in-house that understand the system and can make that happen. And also, of course, if there's company-specific or some kind of proprietary knowledge that you don't want to leak to third parties. Now, in cruise, and this is, in my view, applies to cruise, it's going to be different in some other industries, tried to put some of the different solution areas across which constituents would get involved. Now, computer vision, that's a very mature thing. It works well with scale, and so that's a product sometimes with some consultants to help integrate. Robotics, kind of similar, it's mature. It doesn't mean it's not making progress rapidly, but the kind of things you would want to do in a commercial environment, you could use mature off-the-shelf technology and then some integration. Revenue management and pricing, oh God, I'm not on the, oops. Okay, so this is the chart I was speaking to here. So revenue management and pricing is something I would argue is largely an in-house thing. In cruise, not in every industry, but in cruise, it's an immature area. It's very complicated. It requires constant adaptation and so forth. Supply chain automation, again, in cruise, I would argue falls into that area, as does predictive maintenance. Product recommendations, I think, can cut across all three, depending in particular on the type of product recommendation, and the same with chatbots. We've deployed a lot of chatbots and worked with vendors. We've done custom stuff and also with consultants. So what we do, I want to talk about in-house. So we don't do computer vision in-house, right? So we're not talking about simple problems like these where you label images, put it through a deep neural net, and get a near-perfect classifier. But we do use facial recognition technology in a way that I'll talk about. We're also not talking about doing this kind of stuff in-house, right? Robotics. Now, for some of you, if you've been on some of our Oasis-class ships, we have these robotic bartenders. You get a little tablet, you can design your own drink with some guidance. It makes it, you can watch it make it, it shakes the canister and everything and pours you the drink. And these are actually, these bartenders cost a lot more than the human bartenders we have, right? So it's an entertainment kind of thing, and we can use mature technology to make it work. Okay. So what we are talking about doing in-house are these hardcore enterprise AI problems, right? Where you have a diverse set of human beings in the world, all with different wants and needs and desires and so forth. You're trying to intersect them with some kind of complicated business process, like a sales process, a marketing process, a pricing process, and you want to intersect them. You're doing this in the context of a very complex, noisy world where there's wars and there's pandemics and there's economic crises and so forth. And on top of that, you're doing it with generally bad data, because it's data that wasn't generated for you to do your job, unlike in the computer vision kind of cases, right? It's data that just happens to be lying around the enterprise for compliance or for whatever else, right? So you got to make do with what you have. So this is the hardcore kind of stuff we tend to do a lot of in-house. Okay, there we go. Okay, so coming back to the focus areas, I'll give some examples of some of the kind of things that we're doing, going across this life cycle of the guest, and some things that are AI enabled in these areas. So in particular, for rapid boarding and deboarding and guest flow optimization, we're using a lot of computer vision technologies and some software integration. We came up with this tagline for these efforts as car to bar in less than 10 minutes, right? So this means you park your car in the terminal and you're having a drink at the bar within 10 minutes, which took a lot to get that to work. And not just technology, but some sort of regulatory things and so forth. But that was the mission. You can just go there. If you do the work beforehand to check in on the app, you just kind of walk through using your face as your ID. Also for things like itinerary recommendations, what ports do you want to go to? What places do you want to stop on the ship? Activity and excursion recommendations. So we're using generative AI to match people's musings with cruises. So you can just say, I kind of want to do something relaxing, but also some excitement. I want it to be hot and a little bit romantic, and then it'll come back with some suggestions on that, specific cruise suggestions. Also guest outreach, right? When we reach out to guests to proactively see if they want to cruise, customer service, even on the ship. There's a service desk. People would much rather just chat on their phone to get something done. So we use generative AI for deep personalization there. Pricing automation and optimization of the whole pricing process for the cabin, for stuff you buy on board or off board the ship, for personalized offers. So here we do multi-level AI optimization, making forecasts of what demand will be, of what the willingness to pay will be, and so on, and make that work. Hardcore Industry 4.0. For those that don't know the term Industry 4.0, it generally refers to the next state of industrial automation using sensor data coming off equipment. And so energy and fuel minimization and decarbonization, right? We collect all the data off all the heavy equipment on the ship. Again, for those that haven't seen these ships, they're big industrial operations. Our bigger ships will have 8,000 people on them, and we have a desalination plant getting water for all those people. We have HVAC systems, obviously engine systems to propel the ship. So there's a lot of industrial machinery. So predictive maintenance on that as well is being done from building models of the condition of components based on the sensor data and the history. And then, of course, as I mentioned, supply chain and logistics. So I'll give one example in a bit more detail, revenue management in cruise. And again, we have some of our revenue management team here, I see. So simplistically, revenue management in cruise is more involved than a lot of other things. It's similar to hotels and airlines, but has some unique differences. So it's a capacity limited product, right? There's only so many cabins on the ship. It's cliff perishable, which means once you get to the sail date, you can't sell it anymore. A difference we have from the airlines, however, is there's a very high onboard or ancillary spend, right? About 30% or more of the revenue we make comes from what people spend on the ship. And therefore, we don't really want to have empty cabins. Now, a plane makes a trade-off. They say they're okay with some empty seats because they get a higher average price per seat. They can make up for it with having empty seats because people don't spend much money on the plane other than the ticket, right? You might buy a sandwich or a drink, but it's not like it is with a ship. Also, we start selling cabins 2 years before the sail date. So we have to optimize our behavior over these 2 years to get that maximum yield on the fixed number of cabins that we have. And the levers we have are things like, lead pricing, what promotions you might give, upgrading people to better rooms, gaps in pricing, like between a refundable and a non-refundable fare, when you actually assign someone a specific cabin, how much occupancy you get per cabin, 2, 3, 4 people in a cabin. So those are kind of the levers you have to try to optimize the system. And it turns out as a solution, by forecasting customer arrivals, that means like coming into the system, whether it's through a travel agent or through our website, but by forecasting customer arrivals long-term and short-term, you need both, for the optimization to work, long-term and short-term, along with developing effective elasticities or how changes in price will affect bookings in a given day, in a given ship, at a given time. You can create a nominally optimal inventory pricing and marketing plan, and then can have it in an automatic way implemented. And that's very powerful. And by making the system modular in design and by continuously tracking its performance, you can continuously improve it. So you can improve a forecasting module, you can improve the pricing module separately based on their performance. And then, of course, a lot of A/B testing. A couple of other examples, consumer outreach. So, predicting which leads, we get leads from various places, either from someone going to the website and abandoning, or someone calling and not getting through, but predicting which leads and when to call based on their likelihood to convert. So by studying all these factors, you can say you should call, this person has a high likelihood, so call them and call them at this time. And then using generative AI to help personalize the messaging, with the agent. Also, marine industrial, I mentioned before, it's capturing the global IoT data. That means the sensor data off the equipment, on the heavy equipment, constructing digital twins. If you're familiar with that concept, basically a digital model of a piece of equipment in software. These digital twins, you model and track the performance and enable any kind of adjustments people need to make the equipment work better. It might be to have it break down less quickly. It may be just to make it more energy efficient, but to optimize its operations. And then, of course, optimizing maintenance by predicting component condition. For those who have worked in predictive maintenance, often it's done on a time-based way, so you end up changing out components before they need it, and that costs money, or you end up, even worse, changing it out to, not changing it out, and then it breaks, and then the downtime causes a lot of cost. So there's a lot of value in industrial systems and optimizing maintenance. Okay. Can you advance one chart, maybe? Yeah, there we go. Okay, this is the closing chart. So I already showed this concept here, that the key elements of making this work, maybe an oversimplification or a very high level of abstraction, but the data, the math, the domain knowledge. And there's another talk I've given at one of these DSS events where we go into more detail into the domain knowledge part of it and so forth. But these are the three key ingredients, and then software, of course, to scale it up. Now, the three other things I would say that are critical that wasn't time to talk about today are that test and measurement, which I think everybody knows. You got to constantly test and measure, and not just when you deploy it, but continually over time, because the world changed, things drift, people change, and so forth. So test and measurement. Change management, again, that's a boring kind of consultant kind of topic, but it's actually, many people, certainly on our team, feel it's maybe the most important and the least perfected thing. That more systems fail or don't get deployed because of failures in change management, not because of the actual technology development. And then best practices and technology use. Again, that's something that sounds totally obvious. Like, why wouldn't you use the best technology and the best practices? It turns out, again, I gave another talk at one of these events, one of the DSS events before, about how traditional companies tend to evolve their structures as far as data and analytics go. And it turns out a lot of companies, they were successful in doing a lot of things before data became a big thing. And then as data started becoming a big thing, it grew up heterogeneously in pockets. And so you've got people in charge of various data areas that didn't kind of grow up with that and may just be using what a vendor contacted them about, and so on. So that best practices and technology across the enterprise is another key success factor. So with that, happy to answer any questions.